picture is about the transistor. There are 3 transistors here in this collection of small electronic parts. The original point contact type, the junction type, and the phototransistor. And here is a more complex type of transistor. This is called the junction tetrode. These tiny transistors are destined to play a big part in our electronic age. They will make possible smaller, more compact electronic devices that will need less maintenance and have a longer life. But to grasp fully the importance of these new members of the electronic family, let's recall the wonders made possible by the high vacuum tube, the common radio tube. The roots of the electronic age reach back into the early years of our century. In 1907, Dr. Lee DeForest discovered that a grid of fine wire placed between a filament and a metal plate in a vacuum tube could control the flow of electrons between the filament and plate, and the tube could be made to amplify as well as detect electrical waves. He called this amplifying tube an audion. Weak signals applied to the input or grid of the audion caused similar and much stronger signals to flow from the plate or output. A few years later, 2 scientists, Dr. Arnold of Bell Telephone Laboratories and Dr. Langmuir of General Electric, working independently, found that by pumping out the audion tube to create a very high vacuum, they obtained greater fidelity and stability. Here is one of the first high vacuum tubes that started us on the way to the wonders of our electronic age. By 1915, telephone research physicists and engineers had succeeded in developing methods of manufacturing the vacuum tube with sufficiently uniform characteristics so that hundreds of them were installed as amplifiers, thus making possible the first telephone line between New York and San Francisco. And 3,000-mile transcontinental telephone calls became a reality. This same year, 1915, at Arlington, Virginia, telephone engineers hooked together 500 vacuum tubes to generate enough radio power to send the human voice across the Atlantic for the first time in history. Words spoken into a radio telephone transmitter at Arlington were heard by engineers listening at the Eiffel Tower in Paris and also at Pearl Harbor, Hawaii. 1920 brought the beginning of radio broadcasting, but a vacuum tube radio receiver was a real luxury. Then, the next 10 years gave us talking motion pictures, transoceanic radio telephone service, television demonstrations, and ship-to-shore telephony. With our electronic age in full swing, the coaxial cable, the cathode ray tube, the iconoscope, and the image orthicon, aided by hundreds of more conventional vacuum tubes, gave us television, radar for war, radar for peace, and then microwave radio relay to speed hundreds of telephone calls as well as television programs from coast to coast. The heart of all these electronic systems has been the vacuum tube. But the Bell Telephone Laboratories have added an entirely new and different heart to modern communication systems, the transistor, operating on a new and different principle arising from basic research on solid substances and how the electrons inside them behave. How did it all come about? Well, doctors Shockley, Bardeen, and Bratton and their associates at the Bell Telephone Laboratories were working on a problem in pure research, investigating the surface properties of germanium, a substance known to be a semiconductor of electricity. Their study suggested a way to amplify an electric current within a solid, without a vacuum or a heating element. And after months of calculations, experiments, tests, the transistor was born. The transistor, a new name, a new device that can do many of the jobs done by the vacuum tube and many the tube can't do. Let's see how the transistor and tube measure up. First off, the vacuum tube is power hungry. While a tube like this generally demands a watt or more of electricity, a millionth of a watt is enough for the transistor. Even a makeshift battery of moist blotting paper wrapped around a coin can power a transistor. vacuum tube gets pretty hot, sometimes a little too hot. That's why in complex devices, the tubes must be spaced far enough apart for proper ventilation. Since transistors remain cool, they can be crowded together in a small space. In size, reliability, and ruggedness too, the tiny transistor has many advantages. And research goes on to make it still more useful. Many new and improved types of transistors have followed the early models, but transistors are no longer just an experiment. Here, they are being produced at the Allentown, Pennsylvania plant of Western Electric, the manufacturing and supply unit of the Bell system. Different types for different purposes. The Bell telephone people have lots of jobs lined up for them. Jobs based on the transistor's ability to amplify speech sounds in this way. This is how my voice would sound over a 75-mile telephone line that has no amplifying device. Now, with a transistor amplifier in the line, my voice is amplified so that you can hear me distinctly. This, for example, will mean that in isolated farmhouses, far from central exchanges, the transistor, right in the telephone, will make it easier for the farmer to hear and be heard on his rural telephone. And transistors can replace many of the vacuum tubes used in providing long-distance telephone service. Because they are so tiny, transistors have made it possible to miniaturize many types of electronic equipment. This equipment requires less space and will cost less to maintain. Transistors may also be used in multi-channel telephony, which increases the number of calls that can be carried at the same time along telephone lines. When you dial direct from your town to a distant city, transistors in this route selector may be helping to mark out the pathway along which your call will go. Transistors may someday go under the sea, built right into underwater telephone cables. But transistors go well with lots of other industries too. Many manufacturers have been licensed to produce transistors and devise new applications. Through their efforts, you may be able to get music with a flick of your wrist from the so-called Dick Tracy radio. And with a portable television set, you may be able to enjoy video entertainment anywhere you go. For the military, the transistor opens up fantastic possibilities, most of them in too early a stage of development to be talked about. Transistors will take their place in the complex calculating machines that have often been called electronic brains because they enable man to save days, months, even years in solving mathematical problems. Of course, we cannot build a calculating machine as flexible as the human brain, but even a man-made computer designed to do hundreds of brain-like calculating jobs might need an Empire State Building to house it and a Niagara Falls to power and cool it if vacuum tubes were used in its construction. Substituting transistors for tubes, such a versatile machine could fit into a good-sized room, and power and cooling needs would be relatively low. With the transistor, man has gone far toward matching some of the capacity of the human brain. He has done it with imagination, with the inventiveness and teamwork of the Bell telephone scientists who are looking forward to the age just beyond the age of electronics.